The robot that I'm using is a UR5 robot. It is a 6DOF robot. And in order to interact with this, I've created a GUI, which is as follows. So as you can see in this graphical user interface, I have provided three parameters. One is enter joint angles, enter box position, and enter goal position. Enter joint angles makes use of the sliders in order to set the joint angles of the robot. It has six sliders, and on moving the sliders, these values are getting stored into a list and are passed on to the robot as a form of joint angles. And yes, by the way, these angles are in radians. On the right hand side, you can see that there is a box position and goal position. Uh, it pro it allows the user to enter the XYZ values and place the box in the environment. And the enter goal position is the goal where the box will be placed afterwards. By using the set buttons, I'm I'm using set buttons to extract the information from the text input which is being provided in here. On pressing the execute button, the robot will perform the pick and place operation. The terminal below is used to publish or to show that the box position is being published at 500 milliseconds. So in order to do that, I'll subscribe to the topic which is box pose. Okay. Once the box is attached, top the messages will be published on the topic box pose, and you will see the position and orientation of the box after it's being attached. So right now I've set a random home position for the robot. I'll enter the box position. Let's say point 0.5. Oh, sorry. Point 0.5, point 0.4, point 0.05. Set 0.05 because since the dimensions of the box are just zero point 0.1 mm, zero point 0.1, so relatively it has to be above the ground, so it's 0.05. And in the goal position, let's say in the same point in the opposite quadrant, it's minus 0.5, zero point 0.4, and zero point 0.05. Set. Now both the values are being set. I'll press the execute button. So before I go ahead and press the execute button, one thing you should know that once the box is being spawned here and once the gripper is attached to the box, the terminal will start displaying the values at a constant rate of 500 milliseconds. And the other thing is the up vector in this case, after attaching the robot, the blue axis will be the up vector of the box. And once it is placed, you can see that the blue vector is being flipped by 180 degrees. So I'll go ahead and press the execute button. So as you can see, the robot is now set to a home position. It travels near the box. And now you can see the box is spawned, and after attaching, it publishes the box position. If you have observed that the blue axis is now flipped and it is facing downwards, now the robot moves back to its original position. Okay. Now, as per the requirements, this is the starting position of the box. This is the ending position of the box. So as you can see, we have set 0 0.5, 0 0.4, 0.05. It is 0 0.5, 0.399, and 0.049, which is correct. And similarly for the end position, it's minus 0 0.5, 0 0.4, and 0.05. So this is correct again. And the execution time for the trajectory is around 9 seconds. So this completes my requirements. I would like to go ahead and execute the same task again. I would like to show the box visualization and how it is being flipped. I'll just start a new Python terminal and execute the other visualizer which is used to publish the joint location. Now you can see that the box is already present in the environment. It is because since I've been publishing using latched topics, so it gets the last point which is being published. So I'll execute it again, and then you can see that once the box is being spawned, it will show the actual orientation of the box, which is point 13, which is 000, roll pitch yaw. And after it is being published, okay, now it gets attached, and you can see that the box is being flipped, and this is the final orientation, which is 179 0 179, which is basically 180 0 180. And in terms of yaw pitch roll, it has been flipped.